Okay. Alain, do you want to say a word to introduce Stephan?
Yes. So welcome to everybody. We are now in the panel Digital Tools and New Approaches. And I will immediately give the floor to Stephan Unter from Basel, who talks about the virtual light table.
Thank you very much. First, clarification for the hybrid session. Can everyone hear me with the mic? Is that okay? Yes, it seems so. Perfect. So, first of all, let me thank especially Isabella for the opportunity to talk today and to present a current insight into the development of the so-called virtual light table, a research tool for papyrus reconstruction. And without further ado, let me go to the overview slide. So first of all, I want to give you a very brief introduction into the project I'm coming from, the Crossing Boundaries project. We are working on fragmentary papyri from Del Medina, so I will give you a very brief overview of where we come from and why we have the desire to have this kind of tool. Then I will go over to the virtual light table and show you the concept, the idea we sketched out at the beginning of the project phase. Then probably the largest part will be the live demonstration, so what is happening currently and what is already possible with the tool, followed by coming features and future ideas. And this is also strongly connected to the idea of machine learning, something I'm very, very fond of because my PhD thesis is basically on machine learning. I will not be talking about my PhD thesis today, but it kind of has an impact on this tool as well. Before I start, I should also mention that this tool is more or less a side project programmed by one person, and you will notice what I mean when we come to the live demonstration. But let's start with the project. So, Crossing Boundaries, I already said, it's dealing with fragmentary papyri from Del Medina. Crossing Boundaries is a project, a joint project between the universities of Basel, the University of Liège in Belgium, and the Museo Egizio in Turin. And we are dealing with Ramesside papyri from Del Medina. So I reckon that many of you probably know Del Medina. For those who don't, it is an ancient worker settlement located in Upper Egypt, on the west bank of Plebes or Luxor. And you can see it on the left-hand side of the slide. So this is the remains of the settlement. And during the Ramesside period, so roughly 1300 to BC, there lived the workers and the families built the royal tombs in the Valley of the Kings and the Valley of the Queens. So important people. And the interesting thing here is that the people there had quite a high ratio of literate people. So we have a lot of sources, papyri and ostraca and stuff, compared to what we have left from the rest of Egypt. Our papyri, as we're dealing with the Ramesside period, are in late Egyptian, so a little bit far off the Coptic and Islamic period. But still Egypt. And you can see a couple of examples here. So on the upper side, you see the famous gold mine papyrus, for example. Let me quickly go to the next slide. Here you see the so-called Sprite papyrus, which contains the earliest documentation of the strike behavior of human history. So the workers were not paid well enough, so they decided to lay down work. And but we also have a lot of fragments. So these larger documents, like the gold mine or the Sprite papyrus, we have roughly 200, maybe 250 documents in the Museo Egizio. And in addition to that, we also have like 9,000 fragments of the size you can see on the bottom of the slide. Sometimes with a couple of lines of text, sometimes just the size of a fingernail. And our goal, obviously, is these fragments have never been documented, they have never been studied, so this is the main purpose of our project. And we also want to reconstruct the original documents. How did these pieces belong together? And we have a couple of human experts, human scholars, and my specific task is to figure out ways how to deal with this problem from a technical point of view, with machine learning and stuff. So this is where we're coming from. All the information our human scholars extract from the pieces, also added to a database that contains all the information, the so-called Turin papyrus online platform hosted by the Museo Egizio. Here you can see the entry side when you Google for the site. And if you're a registered user, you get insight into the information available to researchers. So, for example, here is the entry for the Sprite papyrus, and you can see that we have information about the object, like the general dimensions of the object, or the condition, preservation, but also information about the texts on the papyrus. And I should also mention that the documents we are dealing with, we call them heterogeneous documents, meaning that there are multiple text witnesses on one papyrus that may or may not belong to each other. So they may come from different hands, different scribes, different times. They may have completely different contents. So there may be literary text and administrative text on the very same document. And this makes these documents very complex and difficult, but of course also very exciting as well. So all this information is stored in the database. And I mentioned that because this will also be interesting for the virtual line table. And now we're finally coming to the virtual line table. Don't worry, this is not the virtual line table. This is the very first sketch I drew 2 years ago. What it should look like. Well, we need some kind of software where we can use or make use of the fact that we have digitized versions now of all the fragments. Because these 9,000 fragments, they're currently being consolidated, restored, and also digitized. So we have these scans of all the fragments. And now you can imagine what in 2019 we thought, well, we're studying in Basel and we're studying in Liège, and the way to Turin is not that super long, and we always love to go to Turin, of course, but at the same time, it's still a way to do. So why not do the work as digital as possible? But we need a research tool for that. Little did we know about the pandemic, which didn't allow us to access the material at all. So again, the need for such a tool arose even stronger. So this is where we're coming from. This is why we decided, okay, we need some kind of table where we can add fragments to, where we can move them around, where we can add more fragments, or remove fragments, where we can zoom in and out and stuff. And from that, we derived a couple of key concepts, and I summarized them here in 5 pillars or 5 boxes. The first one, very important to me, because I do have a media informatics background, so I'm very much into human-computer interaction and usability studies. So what I wanted to do is to develop with modern web technologies and platform independent. So, for example, I myself am a very big fan of Windows operating system. However, many of my team colleagues are not. They are using Macs. So I want to create a software that is usable for everyone. And it should be designed by usability standards. So, meaning that people shouldn't have to study a manual of 20, 30 pages to be able to use the software. It should be consistent with all the user experience they already have. Then the second pillar is access. So we want to have access both to fragments from TPOP, all the images, all the meta information that we can actually use and that human sources already provide, but also to local images. So if I have additional papyri from another collection, for example, or personal images from a study tool, for example, then I can still add them to the table as well. Or maybe I'm not interested in papyri, maybe I want to study wall fragments. Basically everything that is in a 2D environment would be up for that. Next pillar, selection. So I want to be able to select specific fragments I want to add to the table. Speaking about the TPOP fragments, I want to be able to fit the criteria provided by the database. But later on, I also want to make use of machine learning concepts and machine learning research, and have suggestions given by the similarity rankings. Then organization, so I want to be able to move fragments around, rotate them, flip them around, and I also want to be able to apply graphical filters and any enhancement that could help me to read the document and therefore to help understand it and to puzzle it back together. And a very important pillar as well is the exchange and publication. So I want to be able to save my work and load it later on to do further work when I have more time. Or I want to be able to exchange with my colleagues. And maybe I want to export my result in any possible image format, for example, for publication. So these were the basic concepts we derived and we sketched out in the beginning. And also a very important thing, because the project is funded by the SNSF and they support or require open access to data. So the software will also be published as an open source application at the project end, which will probably be 2020. And here we go. Now we come to the live demonstration, and now bear with me. So maybe there will be bugs, and this will be angry and great at the same time, because any bug I find now I can fix. So let's see if it works. So a little bit of code. And I see that Zoom and the BLT at the same time are bringing down my computer, but it's still working. Okay, so here we are. We are live in the virtual line table, and yeah, you can see that there is table in the background. You can see a lot of graphical user interface elements. You can see a very prominent sidebar. So let's start here. So we have a couple of table commands. I can clear a table, I can save tables, I can load a table, I can export a table, and I can quit the whole application, something we don't want to do right now. Let's start by loading a table. So I prepared a little bit, and now we open a load window, and you can see that I already have 4 save files, 4 VLT files, I call them. And you can already see here that the various file names and how many fragments are in there. So this is not a number, it's just how many fragments are added. For some reason, it looks like a enumerated list. Then when was the document last modified, and who was the last editor? In all these cases, obviously it was me. So let's check. So single fragment rotation polygon, what is that? If I click on that, on the right hand side, I get a little thumbnail, I get an overview, what does the reconstruction look like? Well, it's not very spectacular with one fragment. Do that, and all the contained fragments on the bottom. So if I go to the next one, for example, then I say, okay, I have 2 fragments here, and I see the contained fragments. And with 3, very much the same. I want to go to the 4 because these are very, very high resolution images, and this will break down my computer. So this is still back to fix. So what I also can do is, if I have many fragments or many save files, and I want to look for a specific fragment, all the reconstructions I did with a specific fragment, I can use the filter bar down here. So let's say I'm looking for any fragment called CP, because CP is our number for the fragments, the numbering system, the name. And then, for example, something that starts with CP0, then I see only 2 of the 2 save files that are still there. So it's just a simple plain filter function to find all the save files that contain a specific fragment. It would also be possible, for example, to just click on this one, and then the save files are filtered by this fragment name. Something you can also do is down here with these 2 zip buttons, so you can either zip something, so you can add a save file to a zip archive. The zip archive then includes the VLT file and all the images necessary for the reconstruction, and you can save it somewhere on your desk, or you can send it to a colleague. The colleague can then use this other button here, the import button, can select the zip archive, and it will automatically be transferred to the save folder, and you can open up everything and it should work. So now let's open one of these save files. I typically take this one out of tradition. Okay, and now you see the 2 fragments on the table. And now I can move them around. So I can click them, I can move them around, I can rotate them as I see fit. Now, obviously, every fragment, at least with papyri, has a recto and reverser. So I can use this button here to simply flip them. And now I have the opposite side. I can do this with both fragments. Now, there's an additional button, this little ghost button. Well, I added the ghost because it's the ghosting function. And I don't mean like with texting if people don't recognize you anymore. It's for bleed through. So sometimes, for example, in this fragment on the top left, we see a little bit of ink traces, and we don't know has something been washed off, or maybe it's from the other side of the papyrus and it's just shining through. So we would have to check the other side to see on this particular spot is there ink or not. With this ghost button, you can simply do this. So if I press this button, I can see exactly the other side, just mirror it around, and I see, okay, on the other side there is no ink at all, so it's probably washed off somehow or faded away. Another thing I want to do when I have multiple fragments on the table, and you can all know that this can be very problematic when I have multiple fragments and try to stick them together, is how do I check the other side when I have a reconstruction of the rector, for example? How do I check the verso? I have to move everything. Now, this is even complicated in real life, but even with Photoshop, for example, you have to check, okay, what are the other sides, and how I have to arrange them in the same way. And I cannot be completely sure that everything is fine. In this case, I can simply use a flip function, and you immediately see the opposite side and what it looks like. I mean, in this case, you see that these two fragments don't belong together. So, well, this is really just a test case. Okay, what else can we do? I mean, we can zoom in, zoom out, obviously. So we have the zoom button here. We can zoom such that the whole reconstruction fits to the screen, or we can zoom it to ×1. We'll come to that in a second again. We can hide the whole HUD if you just want to concentrate on the papyri and not so much on the user interface. You could also switch on a light or turn it off. I mean, this is basically just a graphical thing if you need more contrast for the papyrus, if you prefer a bright background or not. Then on the left-hand side, on the sidebar, you see that there are multiple, that every fragment has a single tile, so you can select them, you can remove them from the table, or you can go to the fragment in case you lost them for some reason. And then, of course, we want to add more fragments, because 2 fragments is boring. We want more fragments. So let's do that. You see 2 buttons, T-pop fragments and upload custom fragments. The T-pop button doesn't do anything so far. This is a little bit unfortunate, because I'm still in need for an API to the Turin Papyrus online platform database. We're currently working on that, so the API should be working until the end of the year, and then I will be implementing the overview of the T-pop fragments. But what if we want to add a custom fragment, so something I have stored on my machine, for example? Well, we click on this, and a new window opens, and you have the opportunity to select images for the rector and the verso, either from your local space, or maybe if you have a URL, so a JPEG file, for example, you can use that to just enter the URL to that image, and it will be loaded. We will choose the local ones, and I prepared 2. So let's select this fragment, which is CP9121, just for reference reasons. You can see that the resolution here is already extracted from the image. So if within the EXIF data, you know how many pixels actually make 1 inch, then it will be extracted and you can use that. If that's not the case, then you have a little ruler symbol here, and you can click that, and you can select 2 dots in the image that have a distance of 1 centimeter, and the PPI, the resolution, will automatically be calculated. I need this to make sure that all the fragments later on the table are in the same scaling, because otherwise they will be of different size. But I want them to be in the original size. Okay, now the second image, for some reason, somebody made a mess with that, and it's turned around, so we can move that, of course. So let me rotate it a bit. With these tools, this is possible, and then I can say load, and hopefully, yes, there it is. There is the new fragment. Well, it's nice, but it's not very helpful because there's a lot of background around it. So there is 2 other options I can do. The first one, a little bit occluded by zoom here, so you can't see that. Oh, I can. Wait, I have to get rid of the menu bar. So first I can select the crop box menu, which allows me to create a minimal bounding rectangle around my fragment, like this. This allows me to crop the image to the part I actually want to use, and it also allows me to register the rector and verso, because you can imagine the machine has no clue if I have these 2 images, how these 2 fragments belong to each other, how they relate to each other. So what I have to do is I have to rotate this fragment and to move it until it fits into this box. And if I do this and then press load, let me remove the big one. So now we have a small version of it. And I can move it around, and if I click flip, you see, it stays in place, and it's just as if I would have provided a real alignment, a real adjustment between these two. Also, the ghost button also works very good. Another option would be, if you want to be even more accurate, I could use the Polygon Tool and just add a couple of vertices for a custom polygon as precisely as possible. Well, I'm doing it with a trackpad right now, so bear with me. This is not super easy right now. Yeah, close enough. And this allows me to be more precise when aligning these two fragments. So I'm telling the computer, okay, this is how much you have to move the verso image and how much you have to rotate it such that it fits. Now press load, and hopefully, yes, this looks good. And the other side as well. So, and if I now do the flip, I hope this is working, because otherwise this is embarrassing. No, it's working. So now I can still flip the whole table and see what the verso corrector looks like. So these are all fallback options because, well, if I want to add a custom fragment, I somehow need to register recto and verso because those are both important for us. I hope to make all this process of doing polygon or crop box to make that optional by using machine learning simply by using segmentation. But I will talk about that in a second. Then we have graphical filters, but here it says it's under construction, so far not implemented yet, but it's coming. What else can I do? I can, for example, measure in here. So I have the measure tool, and I can simply select 2 spots, and then it tells me, okay, this distance is 4.7 centimeters. I can do multiple of them, of course. I can also display a grid, a back grid. So every square in this grid is exactly has a length of 1 centimeter, such that you can orient yourself. Maybe you need a scale, for example, for the export later on. You have a little scale down here. And if I zoom in, you see at some point it changes to 10 centimeters because it's just getting too small. Another feature also regarding the size of these boxes and also the measurement is the calibration tool. This was a requirement from our team because it's not very easy to make sure that a certain amount of pixels is exactly 1 centimeter on your screen. I cannot read the resolution of your screen automatically. So what you can do here is, if you want to, you can use a size indicator like a ruler and hold it against your screen, and then say, okay, from here to here is exactly 1 centimeter. You click on the point B, the blue dot. I will not do it right now because I will mess up things. And when then close this window, you can be sure that when I'm on ×1 zoom, that everything is exactly in original size. So the fragment, as you see it on the screen, would be exactly the same size in real life. It depends on whether or not you need it. Actually, I didn't even see that command myself, but our scholar said that's important, and so there it is. We also have an undo and redo function, so maybe I find it, I move it around a little bit, this fragment, and then I decide, no, it was better over here. This is also possible. And then, of course, we can export the table in different ways. So in JPEG, PNG, and TIFF currently, and always in 2 versions. So I can either say, I want just to see what's in the viewport right now. So if I zoom in, for example, and I want to show this particular region here, and I can say, I want just to have this section here, and it will just give me a screenshot of the section. Or I can have the complete table, then it will reduce the table reconstruction such that everything fits into 1 image. And for the JPEG, of course, I can have multiple backgrounds, whatever you prefer for your publication, for example. And I think the last thing now, there's 2 more things I want to show you. First of all, the annotation tool. So if you want to make some annotations, you can say, okay, this is my first annotation, and I'm sure this is correct. And yeah, I can submit this new annotation, and when I now save this file, this annotation will be saved with the file. well, obviously I see that this annotation is not correct, so I can still change that, fortunately, as long as it's not saved. Once the file is saved, you cannot change or delete these annotations anymore. You can just hide them. I did that for the scientific process because, well, sometimes bad thoughts or wrong thoughts are good thoughts as well, as long as other people can recognize them as well. Okay, and the last thing I want to show you is that there is rather new, also a multi-table solution, so you can have not just one, but multiple tables at the same time. See, it has to load a little bit. So here we have table 0, because computer scientists always start with 0. And then you can go to table 1 and can just do something else. Let's just very quickly put another table in here. Okay, and now I can just switch between these two tables and have open, well, as many as possible, or let's say as many as the machine can do. And that's basically it for the moment. This is what the VLT can currently do. This leads me also to the next slide of my presentation, coming features and future ideas. So what are things I'm currently working on? Well, one I already mentioned, the connection with the Turin Papyrus online platform. So I want our scholars to be able to select from all the 9,000 fragments we're studying very easily, and also with a filter option by the database attributes. This is a very important thing, and as soon as the API is there, I will absolutely work on that. Then I need better support for large image files and more image formats, also including IIIF. The graphical filters, also something I have to work on. I know that Isabel has made a lot of progress on this side, so maybe some time for collaboration. Then also another idea that might be interesting is to integrate the option for multiple layers of fragments. So for example, if you have a fragment, not just photographs, but also backlight or multispectral imaging, then you could add those images as well. And then on your table, you could just switch between different view modes. You could see the reconstruction in multispectral light, with backlight, and so on. So with backlight, for example, you could check better, do the fibers match, or with multispectral lighting, you see something that otherwise you wouldn't see. So this might be interesting. And also interesting would be to integrate machine learning aspects. And here I will give you a very, very small glimpse into what I'm doing in my PhD thesis, what I did, because this is very early research. For example, the segmentation. So a very easy task is to train a machine and to let it figure out, okay, here you have a papyrus, just mark me all the pixels that belong to this papyrus. And if I know the extent of the papyrus, the dimensions of the papyrus, then I can very simply cut out the papyrus from the original image and know exactly where it is in the image. And this would render the whole masking process I showed you earlier, the bounding box and the polygons. This would render this completely useless because I could simply create a mask for the recto, for the verso, and then take those two and put them together and rotate them until the overlap between those two is maximum. And then I have the registment between those two objects. So my hope is, and this is what I'm currently trying to implement, that you simply select two images for your fragments and the computer does all the rest. This would be nice. Also nice would be to have an automatic facsimile, so the very famous finalization, also not very much a problem because it's just basically a multi-class extension of the segmentation case. So what I did here is I added additional classes, so my computer recognizes the background, then the color scale, because the color pads sometimes they interfere with the papyrus. Then I have papyrus as a class, black ink and red ink. And the machine can learn this, and for every pixel, the machine tells me, okay, it is, for example, black ink or papyrus, and in the end, I can decide to just show all the pixels that are black or red ink. And here, for example, you have such a case. So this is machine generated and done by me. And you can see in white all the rubra and all the verse points, and in a little bit grayish, you see all the black ink. Even darker is the papyrus, and in black there is the background. And this absolutely works fine. I mean, we can always talk about the quality of the segmentation. There is a little bit to the left and to the right sometimes, but yeah, the quality is actually not that bad. And yeah, this is not the only thing I want to do with my machine learning research. So I'm currently studying also a lot of other aspects of the papyri. And the final goal I would have for the VLT would be that I add fragments to the table, and then the table tells me, okay, you have chosen these 2 fragments, for example. Have a look at these fragments, because given the multidimensional fragment space, so to say, given by all the features that I extract from the fragments, these fragments have the smallest distance to the fragments you already selected. And this would give a hierarchical list, and you can have a look at the items at the top, and maybe, hopefully, they are the best fitting options for your reconstruction. And that's it. That's currently what's going on. And if you have any more questions, or if you want to contact me with questions, you can always go to our website, crossingboundaries.unbas.ch, or you could write me directly, with a QR code to get directly my contact details. And with that, I thank you very much.
Thank you.
Thank you.